recording? I think so. Yeah. Okay, perfect. So Protect welcomes you to the Painpoint workshop, problems and challenges to tackle through innovation procurement of climate services based on Earth observation. The agenda that we have for today is as follows. We will skip this time the tour de table, as the participants are still joining, and we will go directly to the context and objectives of Protect, which is to prepare a PCP related to climate services based on Earth observation. On point number 2, we will explain the EAFIP methodology and focus on step 1 on the needs assessment and the expected outcome of this workshop. Then we will have some questions and open discussions, so you can participate freely in these discussions. And finally, we have some next steps, so what is coming after this workshop. So let's go to the first point, the context and objectives of Protect. The mission of Protect is to prepare and equip a community of public authorities, buyers, to undertake one or more joint cross-border or coordinated pre-commercial procurement processes with the purpose to steer the development of the next generation of climate services based on Earth observation. As a matter of fact, Protect is strategically positioned to answer to the call, the Horizon PCP call that you see on the slide. And this is expected to be launched in fall 2024 with a funding amount of 19 million euros. The call is on the customization, operationalization of prototypes and end-user services in the area of climate change adaptation and mitigation. So through Protect, the public authorities and buyers that are facing or who are facing similar pressing needs related to climate change will be connected and will be supported to formulate concrete and realistic needs for Earth observation-based climate services applicable to the 5 application domains of Protect that can be subject of the future PCP or possible PPI, so public procurement of innovative solutions of pre-commercial procurement. So here we have a first question for you to set the context and the discussion. So the question is, what is the experience of your organization with Earth observation data and or related services? So I will give you some time. So yeah, you scan the QR code for Mentimeter. With your phone, you can do the scanning. And I will do it also myself to see the time that you need to do that. We go, so you get prepared. These are the instructions. Okay, so you can do this and keep on joining with Mentimeter. Okay, can do more of you can participate. I will go to the next slide. Yes, I will give a little bit more time for you to join. Sometimes it takes a little time until you take out your phone, you scan the code and you open it up. So keep on doing that. And I am going to move to the question now. Here it is. So you can vote and see what the results are. Okay. So we have 3 votes. So people who are aware of Earth observation data and services, but they are not using them. So that's perfect in this case because we're going to learn more about them and see what are the common needs that you have and in order to prepare those common needs for a possible innovation procurement. One of you is currently using them, so it would be interesting to see who voted yes and how are they using the Earth observation services. If possible, I would ask the participant who voted if he or she wants to let us know how they're using Earth observation, that would be great. Otherwise, you can also type on the chat if you would like to share how it is that you're sharing or using Earth observation.
Yes, I can do that. My name is Wim Looyen. I work for the Netherlands Space Office. which is a public authority, and as part of the national space policy, we buy satellite data for high resolution satellite data and radar data for use by the Dutch user communities. So as a service, we operate that in a satellite data portal.
And okay, so how do you use this information? Is just in the portal, different information that is available to all, let's say, as a public information, or is it used by institutions only?
No, it's for use by everybody,
Mm-hmm.
from citizens to public authorities to science to companies, etc. But
Okay.
the
Okay.
only limitation is that you have a Dutch IP address.
Okay. All right. So in principle, companies can use this information to develop services.
Yes, that's correct. That's
Okay,
basically
great.
the aim why we have set up this
Mm-hmm.
portal in line with the national space policy. Yeah.
Yeah, very interesting. Yes, just to foster also innovation, let's say, using the Earth observation data.
Yeah.
Great. Thank you, Wim. Thank you so much. Okay, let's move a little bit then to the next slide. So see now to keep you refreshing on the objectives and key actions of Protect, I would like to mention that we want to define and aggregate needs and define functional requirements for climate services, explaining, fostering, and supporting a buy-in with impact approach. That's one of the key actions of Protect. To prepare the operational ground for one or more pre-commercial procurement processes. So that's the aim of today. We'd like to see what are your common needs and what type of challenges could be used for in the setup of a procurement. What is that we need? What kind of innovations are responding or we responding to your needs or unmet needs? And why do we want to define functional specifications? The functional and performance-based related requirements are the appropriate means to favor innovation in public procurement, and they should be used as widely as possible. This is also mentioned in the uh, European public procurement directives to foster innovation. And what we want to do when we formulate these requirements is that you describe the requirements that an innovative solution must meet, giving suppliers sufficient space and freedom to come up with their own ideas. And by doing so, you probably obtain also solutions that you have not even imagined beforehand. Doing this, having functional specifications is really triggering innovation. Actually, there's no innovation without a functional specification. So we want to make some questions to you in order to describe, to get from you the needs that you have, and try to define in the best way the service and product that will fulfill your needs. So we need to know what problem is that you want to solve, what is the cause of the problem, and answer some questions that will give insights into how the problem can be tackled. Here you see some of the techniques, or one technique that is the functional analysis system technique, that is a diagram that is used to define the scope of the problem and look into the logical association of the functions, asking questions on, for example, how does the function tackle the problem? Why do you want to tackle this problem? And see whether they are primary or secondary functions. But this is going to be embedded already in the questions and in the methodology that we will have for the workshop today. So let's look into the problems and risks that are more common when we think about the application domains of Protect. And let's look into the agriculture and forestry and other land use. We see some examples of common risks that are the food shortage or deforestation or drought. And these risks need to be tackled or reduced in order to have a substantial contribution to climate change. If we look into the EU taxonomy regulation that is describing the economic activities that could be sustainable in order to make the right investments, you see that this substantial contribution is mentioned and in relation to reducing or preventing this type of risks, these risks that have an adverse impact in the environment, on people, on the assets, on nature, etc. So these are some examples, and we also had formulated already one example of common problem during the high-level conference in Barcelona. This was the illegal dumping of waste. At that time in Barcelona, the discussions on illegal dumping of waste were very interesting. It was mentioned that this is a collective problem that can lead to dramatic consequences. For example, the toxic material is carried by the heavy floods and contaminate the soil or the water, causing all sorts of problems, including health problems. And the question was, how can Earth observation help with waste management and climate change? That could be done by contribution with data that helps detecting, monitoring, warning, and alerting the illegal dumping, and help the public authorities in the value chain to respond better and provide a better service using the information, the data that is fed into the systems. So this is one of the problems, the challenges that were proposed during the conference. And we would like to know in this question too, whether this is a problem that is relevant to your organization or not. So is detection of illegal waste dumping a relevant need for your organization? You can refresh, if you enter already to Mentimeter, you can just refresh it and we will have a vote for the next question. So we see the players. And let's move, yeah, becoming. Let's move to the next question. And you can vote. Let's find out if, okay, so this is a relevant problem for most of you. Okay, well, that's interesting. Let's see what other problems are for other participants. So let's go back to our presentation and let's see. Before we do that, we would like to have a short introduction on the potential of Earth observation for all of you. And I would like to ask Joanna to please take the floor so you can enlighten us with the information you have.
Thank you, Ana Lucia, and welcome everyone to our Paintwork workshop. I'm Ioana Simanaroshka, and I'm working with Aerospace Valley, and I'm gonna present you a bit about Earth observation and how this is working with the climate services. So according to the European Space Agency, the Earth observation is defined as a process of acquiring observations of the Earth's surface and atmosphere via sensors mounted on satellites, aircrafts, drones, or at the surface, resulting in data in the form of digital imagery. In the last several decades, Earth observation has been an essential tool for monitoring the planet, its environment, the human activities on the planet, and also the impacts. For example, Earth observation has been fundamental to monitoring climate change over the past few decades, as satellites provide a clear, uniform, and continuous picture of changes across the entire planet. The vast amount of data collected through Earth observation is processed and converted into actionable information for the end users across several industries. Two supporting technologies that are enabling this intermediate step of processing Earth observation data are artificial intelligence, or AI, and cloud computing. When it comes to cloud computing, the advancements over the past few years have enabled the sufficient storage and processing of digital data, thereby facilitating the conversion of Earth observation data into useful analytics. And artificial intelligence, which is the field of computer science using the field of computer science dealing with making intelligent computers programs it has allowed huge amount of data that have been collected from satellites on a daily basis to be combined effectively, allowing the users to derive the needed insights. So these two together, the convergence of AI and cloud computing, have enabled the rapid growth of the Earth observation market, leading to development of several applications of Earth observations. And now, if we go to the next slide. Thank you. We will see the Copernicus program, which is one of the largest Earth observation programs in the world and is being managed by the European Commission. And the objective is to monitor and forecast the state of the environment on land, on sea, and in the atmosphere in order to support climate change mitigation and adaptation strategies, the efficient management of emergency situations, and the improvement of the security of every citizen. Served by the dedicated Copernicus Sentinel satellites, the data collected is then integrated with non-satellite sources to provide reliable and up-to-date information about 6 different thematic areas: land, marine, atmosphere, climate change, emergency management, and security. But if we go to the next slide. Thank you. I bet that you are wondering what is the role of Earth observation in the climate services. Well, as the climate crisis continues to evolve with the ongoing global warming, the governments and businesses around the world are focusing on climate adaptation and climate mitigation initiatives. Therefore, Earth observation data is playing a crucial role in the development of climate services, both focusing on adaptation and mitigation. The satellites, which have been monitoring the Earth continuously and helping our understanding of climate change, provide vital information regarding the state and the evolution of the environment, as well as regarding the human activities on the planet. As a result, climate services applicable to several industries are expected to integrate Earth observation data into their products in order to take into account the environmental factors and changes over time. There are several emerging climate services that have already started to integrate Earth observation data into their development. From providing extreme weather alerts for better disaster preparedness to both governments and businesses, to delivering crop level insights to farmers, enabling water savings and improving overall yields. There are a number of climate services currently available in the market across a big number of industries. And now we're going to go to our application domains to see how climate services apply to the 5 application domains. As you know already, we have been having different point workshops for each application domain of our project. And now we're going to talk about the one for agriculture, forestry, and other land uses. Well, as a definition, this application domain includes crops, forests, animals, and also microorganisms, because in this application domain, we are also tackling the bioecosystems. And when it comes to the climate services using Earth observation in this application domain, they can contribute to a more optimized and sustainable exploitation of the land based on precision agriculture, natural resources management, as well as counter the growing challenges related to the climate crisis, like, for example, providing forecasting and alerts on extreme weather events. And now, if we go to the next slide, please. Thank you so much. Here we have an example of usage. So in the category of environmental monitoring, we can focus on carbon capture and content assessment. And as a list of applications, the monitoring of the agriculture vegetation and also grassland cover through Earth observation can help inform carbon sink capacity of different terrains. Earth observation can also be used to monitor the maintenance of agriculture practices which pertain to dioxide carbon sequestration. And in the right side, we have a video which is giving you, it will give you a better overview of how the dioxide carbon is being emission. And if we make it a bit bigger, is it possible, Ana Lucia?
Yes, let me see. How do I do this?
Mm.
Let me see here. No, that's on the title. I have to open it up outside.
Oh, but
Wait.
I think it could be okay, visible. Is it all right for you?
And now it's actually too big, but
Can you
it
see
was
it now?
just, yeah, now it's just fine.
Oh, thank you so much. I think now it looks good. So if you take a look at this video, it's being presented where the carbon emissions are being the highest, and how all the process is being is happening, and in which hemisphere the emissions are higher, and which hemisphere is having lower emissions of the dioxide carbon as well. And at the same time, you can see all the process and how it can be seen from the satellites as well. And here are some statistics. This video has been made in 2004, so I think that the statistics have increased in the meantime. And you can also see some explanations how the dioxide carbon emissions are being absorbed by the ocean, and where are more emissions as well.
Mhm.
Here's a representation of how over the summer the dioxide carbon emissions are getting lower, because the plants and the trees are absorbing more and more, and how over the winter they're increasing because the plants are going to uh, hibernation. I'm not very sure how to express it. But yes, it gives you a better overview regarding how these measurements are being made, and on which parameters they are being based on. And now I can give the floor to my colleagues. And if you have any questions, please don't hesitate to ask them.
Are there any questions for Joanna at the moment? Otherwise, we go with Kevin. Okay, so the Kevin is going to tell us a little bit about what climate service is Protect looking at in terms of the taxonomy that they have been researching. Thank you, Kevin. You have the floor.
Hi, Ana Lucia, and hello to the rest of the audience. I will briefly discuss the taxonomy work that we have done within the context of Protect. Perhaps, first of all, it's important to state that we did not develop a unique taxonomy system. That's a very lengthy project. So instead, what we did was to look at existing taxonomies, mainly from the Earth observation domain, as well as from the Earth observation field, and also with the context or with the view of the lenses of the 5 application domains of the project. And from that, we derived and we extracted the elements, the climate services that we thought would be relevant. And I think what we're trying to do with this work is to specifically provide support to public procurers when it comes to identify what sort of the challenges that they have within um, their systems. Could be the forestry management, could be related to CAP, or could be related to water supplies and so on. So we know that there are several applications within the agriculture and forestry domain, and the idea is that those elements could be reflected in the in the taxonomy system, but we also are aware that there might be some elements that they're not there. So we also are intend to, if needed, update the system that we have provided as the project progresses, and we identify more information from that. So just to summarize again, this is a piece of work that is there to support the implementation, the communication with the stakeholders, specifically with public procurers, and to bring a little bit of light into something that could be very complex, and to facilitate the identification of your climate services or climate challenges at national, regional level. So that's perhaps as much as I wanted to say from my side, but we'd be happy to extend if additional information of the additional questions are present. Thank you.
Thank you very much, Kevin. Are there any questions from the audience for Kevin? Okay, not for now, Kevin, perhaps later, let's see. But just to give you an example of functional requirements in the agricultural, forestry, and other land use domain, we have here some, let's say, functionalities that can be provided with the potential of Earth observation. We're using here for the functional description, the active verb and the measurable noun, as you can see, that will help us also to describe our needs. For example, here we have monitoring of the state of a forest inventory, tracking and detecting forest and land changes, identifying and mapping plants and trees, detecting stress in plants before they are visible to the naked eye, or monitoring large areas. So these are some functional requirements that could give you a hint for the work that we will do in this workshop later on. Okay, so now that brings us to point 2 of this workshop, that is the EAFIP methodology. Since we are preparing a pre-commercial procurement, also identifying what procurement challenges there are from the public authorities, we will apply a methodology that is a step-by-step approach developed within the context of the European Assistance for Innovation Procurement of an initiative of the European Commission of DG Connect. And this methodology developed together with Corvers provide this approach on a state-by-state basis, starting from the very basic research of latent needs to the needs assessment and prioritization, engaging users in work sessions and evaluating the common needs. Then by developing some use cases, we can define keywords and perform a state-of-the-art analysis where we see what is in the market, but also we look at the available patents, standards, and literature, and also map the possible suppliers and companies that could be invited to an open market consultation, which is the next step, because we want to know the technology readiness of the solutions that could tackle the common needs or the needs that the procurers have. So in the open market consultation, the market is informed about these needs, and it's also asked to challenge the findings that we have from the previous state-of-the-art analysis. We also test the business case and ask about the setup of an envisaged procurement and the provisions that we would like to insert. So this also gives us an insight with the feedback from the market to ask for the preparation of the business case, but also the tender documents. So the next step is the business case. A cost and benefit analysis is performed. The analysis of different scenarios is also conducted, and all this information will help us to define the procurement strategy based on the technology readiness of the desired solution, and also give us more insight into the provisions that we want to have in our tender documents and in the contracts. For example, for pre-commercial procurement, there's a standard approach in which the intellectual property rights is left vested in the contractors so that they can exploit and commercialize solutions. And in this step, we have decided already if we choose for pre-commercial procurement, that is the procurement of research and development services, because there's a need for R&D, or if the solutions are at higher TRL levels or closer to the market, we choose for an approach of public procurement of innovative solutions and one of the procedures that are available under the directives. So we prepare the tender documents with this defined strategy, and we go to the next step, that is the procurement procedure itself, with the tender process, the evaluation of proposals, the award of a public contract. Along this process, we observe, of course, the principles of the Treaty on the Functioning of the European Union, which are the transparency, equal treatment, non-discrimination, proportionality, competition. And the next step is the contract management, to monitor the milestones and the deliverables. In the case of PCP, that is a competitive phase approach. We also have phase 2 and phase 3, in which we evaluate proposals and we evaluate the results of each phase. In contracts regarding public procurement of innovative solutions, we also could monitor value engineering clauses to see how can added value be integrated and provided by the contractors. The last steps of this methodology include the evaluations and the lessons learned as a continuous cycle to see how we achieve the results, whether we are within the benchmarks that we establish, the key performance indicators. And in the last step, this is the post-contract management. So we look at those provisions that subsist after the contract. For example, the monitoring of IPR obligations, such as royalties, for example, or the obligations to commercialize the solutions after a certain period of time, which is normally the case in pre-commercial procurement. We could also look at obligations on standardization or the link with venture capital investors. So for Protect, at the moment, we are looking at these preparatory steps that are the 5 main steps in the EAFIP methodology. We call these 5 steps the EAFIP business case methodology because it ends at the value calculations of our business case to see which trajectory we follow. So in these 5 steps are the needs identification and assessment to know what the problems are, what the requirements are. As I said, with use cases defined, we can look into keywords and perform a prior art analysis, which is an analysis of what the market can offer, but also an intellectual property rights search to see the patents, the standards. And this describes the state-of-the-art analysis and also the key contenders or the key suppliers, owners of intellectual property rights. It's also important to have an analysis of the standard landscape to define the degrees of consensus on such solutions. And with these findings, we go to a market consultation to engage with the market to see what the market can offer with regard to the requirements, the needs that the public procurers have. And the results of this market consultation would give us a possibility to build up a strong business case, to do value calculations and decide on which trajectory we go, whether we need R&D or not. And we defined, as I said before, when I presented the whole blown up EAFIP methodology, how we define our tender documents. So at the moment in the Protect, we are here at the very beginning on the needs identification and assessment. That's why we want to know the problems that you have and how we can build on that to go to the next step on the prior art analysis and the IPR search. Okay, so let's go now to step 1, needs analysis and prioritization. So here we have the question of what challenges or problems do you face, whether they are current, whether they are future. We know that we have pressing challenges already with climate change. So this is why we have this workshop, and this is why we want to have this analysis of the functionalities that you require for a function-based approach in the specification of potential tender documents in the future. And the expected outcome out of this workshop is the following. We want to have a description of the problems, the needs as functional requirements. We want to have use cases or one use case related to climate services using Earth observation data. And also define, ideally, a value pilot, a scenario related to new or to be developed climate services based on Earth observation. So here we can start our discussions after I explain a little bit about the methodologies that we are using and which are embedded already in the way we are handling and the way we are applying this workshop. So we want to use these value methodologies to prioritize and fine-tune needs based on the climate challenges identified in 5 application domains. And the outcome of these workshops will help us to define the keywords on functions and performance to perform the state-of-the-art analysis and give an overview of the needs and the subsequent procurement challenges that could be addressed through one or several pre-commercial procurement. So what are the methodologies that have been embedded in this workshop? There are 3 main methodologies that could be found also in the value management standard. That's the functional analysis system technique that states the scope of the problem and asks what the problem, how the problem can be solved, why the problem can be solved, and the relationship between these functions that you describe. Also, the value stream mapping and value stream design, these are based on the lean methodologies in order to define the situation as it is and the desired situation, the dream situation, and the steps that we need to take in order to achieve to this dream situation, understanding what is the value in those steps. Okay, so now that we have seen a little bit about this methodology, then comes the next question, and we want you to write on the Mentimeter, what are the most pressing climate challenges problems that your organization faces at the moment? So there you have, again, the QR code, if you didn't have, or you can refresh the actual Mentimeter. So I'm going to pass, I hope you have it already, but I'm going to need to go to this here. You can also use the code of Mentimeter, that is the 179616101, and you can vote entering 3 words, or in each of the spaces you can enter a little bit more than 1 word. So you can do that. I will give some time for you to do it. Want to see what your problems are. Let's see. Okay, energy resources, we have fire, drought, deforestation, floods. Okay, we have twice the word drought. Anybody like to, I have more. We have energy resources, scenarios, okay. Okay, then I would like to have your participation, anybody of you, perhaps those who have mentioned droughts, could give us an insight. Okay, I am passing to the next question, but that's not the idea. Okay, I'm going back to here. So I would like to give the floor to any of you who would like to voluntarily explain the problems that you foresee. I don't know if anybody is willing to do so, or I can ask more questions to you. No? Perhaps I can ask some of you that I know, if you could give us some ideas of the problems that you are facing at the moment in your organization that could be tackled by the better use of Earth observation data or services. And I know, for example, that and in Agapa, you have a project using drones to obtain information from the field and from the sea. And perhaps I can ask Encarnacion to let us know the problems that you're facing at the moment, if possible. So you have the floor, Encarnacion.
Well, thank you very much, Ana Lucia. Yes, we are preparing a procurement to develop some kind of solutions for observing the Earth, but with a high degree of resolution. In this case, where people working in the countryside cannot access to these areas, and related with Control Ed for PAC agriculture politic, common politic, and now we are defining some uses cash
Use cases.
use cases. Sorry,
Mhm.
to identify the situations in
Mhm.
which it is necessary to develop these solutions, and mainly we need them to characterize the network of roads in agriculture areas, and also to identify um, um, crops that need to be sorry, I don't
No
find
worries.
the words.
That's okay.
We need it also for fishing, for
Mhm.
inspection in fishing,
Mhm.
and for illegal reasons. This is another cash use.
Mhm. Okay, that's interesting, Encarnación. So, okay, you are already working on this project, and perhaps also to complement this project, you will need more Earth observation data, and in that regard, I would like to ask you, for example, if you have this defined some data that will be needed for that, or whether you already have this data or not.
I'm sure we will need this data. In fact, we are using this data coming from Copernicus, because most
Okay.
of the control aids from the political agriculture, common agriculture policy, is made up of with satellites. We use actually data coming from satellites to do the control of this kind of ads. But still, there is some situations, for example, agroenvironmental ads or conditional ads that people need to go to the countryside. There is a share of the control that need to be done directly on the countryside, and in these cases, satellites have a resolution that is not enough, and we need all the kind of instrument to take this information. That could be drones. That could be this kind of solutions coming from drones.
Okay. Because according to the presentation of Joanna, you can complement the information of data from satellite with drones and with sensors. Perhaps
Yes.
Joanna can give us some insight into that, and perhaps also Encarnación could let us know the type of information that is not captured by satellite and that you need.
Okay.
An
Yes.
example.
Well, this is a very technical aspect, and perhaps it need to be expressed in terms of resolutions. Resolution that perhaps this data I can send it to you later on, because I don't have now this data.
Okay. Joanna, you can contribute perhaps to a little bit on telling us how can this be tackled if there's something that due to the resolution of satellite is not being captured, and how could it be done in a complementary way?
So as for the moment, as far as I know, there are difficulties also regarding the same problem that we're discussing right now, but it's more like a technical problem, and I know that like there are advancements that are being is being worked on in order like to be able like to give a better resolution through Earth observation data as well from the satellites. But there are also complementary informations and data which, if, for example, the satellite is not covering, it can be complemented by the drones or by the aircrafts as well. So it's like a broader technical insight for the moment, because of course the satellites can't cover all the surface of the Earth, obviously, but the industry is working on trying to find better solutions in order to improve the technology nowadays. I hope this answered to your question. And in case that you want to tackle this in more details, we can do it later on, and I can also bring some expertise into the discussion if you'd like.
Thank you, Joanna.
Okay.
Yes, that would be
Yes.
nice also. So, Encarnación, just
Ana
I would
Lucia.
like, yes.
Yes, I wanted to also to say that in Agapa we have another project, a second project that has been funded by Lightwatch Eric. It's a big project for infrastructure investigation on biodiversity, and is set up in Andalusia. This big project. And there was a call for users, and Agapa is now implementing a project in our food. And just I think that in the next month, I can send you also the information, because in the next month Agapa will launch a micro satellites to get this kind of data that you cannot get from satellites, from the big satellites, also because the frequency of the data are not enough for the kind of problem that agriculture has. So this is another possibility. Agapa now is exploring these two solutions: microsatellites and also drones.
Okay, interesting. Okay, thank you very much, Encarnación. And I would like to also ask you whether you have needs related to drought and also deforestation, and are these something that you could also look into or not?
Yes, drought is another important topic we are studying, but this is a very technical topic, and I can ask somebody from my institution to explore the possibility that Protect could offer to this problem. Also, there is another department in agriculture and also in environment administration that could be interested. I think they answered the
survey,
the questionnaire. Yes, I remember.
Yes. I don't know if they are participating today. I think they were invited as well, but we can follow up with them as well.
Okay.
That's good. And I ask you because in the previous workshop, we were in the workshop on energy and utilities, and there was an interesting use case proposed, and that was a case in which, it would be the ideal situation would be that you could actually map or have data on the whole cycle of water. So to connect the supply and the demand, for example, in case you have a drought, you can predict this drought, but you could also know the availability of water, whether it is from, for example, the channels, or whether it's, for example, from wastewater that can be treated and used, for example, for the farmers, let's say, that suffer these droughts. So that was one of the cases that was formulated in the previous workshops. And you mentioned that another department is in charge of this very technical issue on drought. correct?
Yes, yes, I think so. I think so. I think that the department was this that answered the questionnaire.
Okay.
So I can contact them again, or perhaps if you can deliver the result to them.
Okay. Yeah, thank you very much. Anybody who would like to participate or mention something, I don't know, you have mentioned here also forest depletion, forest deforestation, okay, salinity intrusion. Who mentioned salinity intrusion? Perhaps you can give us some ideas on this problem. Anybody? Please dare to participate. It's okay, or you want to use the chat in order to do that. That's also possible.
Yeah, salinity intrusion is written by me. I am from Bangladesh, working in a policy research institution, Center for People and Environment. We are also working on salinity related issues. In Bangladesh, there are 24 coastal districts adjacent to Bay of Bengal. Out of these 24 coastal districts, 17 districts are salinity prone. And among those, almost 6 districts are highly salinity affected area, and there is agricultural production is totally restricted almost. And not only so, in recent times we have conducted some studies on impact of salinity on health issues, and we have found reproductive health problems are increasing in those districts because of salinity. So this is the major problem for some parts of coastal districts, and we are trying to develop climate resilient health delivery system and also climate smart salinity tolerant agricultural practice for the coastal people. This is on.
Okay, that's very interesting. Thank you, Mohammed. And are you using Earth observation data in your systems?
No, we only applied Earth observation data, detection of methane concentration in the atmospheric level of Bangladesh. We have only conducted one study, but even now we did not apply artificial intelligence or cloud computing in terms of salinity or drought detection. But we are interested to apply Earth observation data.
Okay, that's interesting. And I would like also, Joanna, whether there is you have some cases or some information that could be relevant or already services provided in that regard?
Regarding
The detection.
The detection of the salinity, you mean? In my knowledge, personally, I don't have anything like that in mind, but I can try to check it out with our members and our experts in order to come back with a proper answer regarding this question, if that's fine for you.
Thank you very much. Yes, Joanna. And Mohammed,
because I think at least for me it's quite the first time when I'm hearing about this kind of problem, and I definitely have to take a look into it first before providing a feasible answer.
Thank you. Mohammed, you were mentioning that there were problem in the reproduction of the plants or living species. Could you, I don't know if I understood correctly.
There are multiple problems are arising in the salinity affected area. Soil health and soil fertility is totally degraded. And, agricultural production is not possible in some parts, and also health problems are increasing.
And when you mean reproduction, you mean in plants, in animals?
Plants, mainly plants. And
mainly
in
plants.
Bangladesh, mostly livestock intensive area, Bangladesh. But due to lack of fodder, the livestock is also restricted in those areas.
Okay. I don't know if we have the similar problems in Europe. Don't know if the participants here could let us know. Don't know, for example, even that in Andalusia, we experience this problem also in the soil, in their soil for agriculture. Don't know if you have a similar problem or not.
Salinity in our Bangladesh is higher than European countries, I think, because I was in Netherlands and also Germany. I found there is salinity level is not more than 3 ds, but in Bangladesh, in some area, salinity increased up to 37, 38 ds.
Okay. Okay, thank you so much. Anybody would like to make any comment on that? Or I see also the another challenge that you pose is groundwater depletion. Somebody who mentions this would like.
I have also
Yes,
mentioned groundwater
good,
depression, and in
good.
Bangladesh is hottest spot of climate vulnerability, and all kinds of climate vulnerability are in Bangladesh. Drought is one of the major problem in Bangladesh, and not only in drought prone area, we have almost 14 districts are drought prone, but in other parts of Bangladesh, due to extraction of groundwater. Now, almost all of the Bangladesh groundwater level is more than 3 to 4 meter depth, and in most areas during the winter and summer, groundwater extraction is not possible. In some pockets like Noakhali, like Kumilla or other some hill area, in hill tracks. During summer and winter, people don't get drinking water because of groundwater depletion. So it is another major problem in Bangladesh. It is not only a specific area; it is all over Bangladesh.
Okay, thank you very much. Yeah, that's for your contribution, Mohammed. And let's see if anybody wants to also take the floor, give us your insights. Yes, I think nobody also in the chat. Not yet. Okay. Somebody mentioned scenarios. What do you mean by scenarios? If the person who mentioned that would like to give an insight or not? No? Okay, it's okay.
Don't be afraid. This is not like a lecture in school where you are getting wrong or right answers. So
Yeah.
you can always jump in.
Yeah, we want to see what challenges you face. So to define some common needs. The person who mentioned forest depletion, anybody who like to make the comment on that? No? Okay, that's fine. It's okay. Let's go then to, we have this question. Yeah, you already replied to this question, but we have another question. Perhaps in this question, you get a little bit more time. So I'll keep my slide so you can use the QR code. In this, you want to type, how can Earth observation data or services support the tasks of your organization to contribute to climate change mitigation and adaptation? So thinking about, okay, we have these main risks and these main problems that you have just mentioned, like deforestation, like the risk of fire, the risk of drought. How can Earth observation can help your tasks? So use your QR code. I'm keeping these the QR code here so that you go to the Mentimeter and please use it. And I'm going to go to this page. So to go back. So there's no correct answer. All the answers are, I see, not incorrect answers. So there's all the answers are correct. So you can type inside and see how you can use Earth observation. Okay, I think for some reason I will give. Can you insert your? Okay, now it's coming. This is question 2. Let's see. Yes, now it's working. So you can write a short sentence. You have 1 minute, a little bit less than 1 minute. Okay, let's see. Your participation is really important. We're trying to define after this one use case, at least.
Ana Lucia, is Kevin here.
Yes, Kevin.
Maybe to go back to the discussion about salinity, I just conducted a very quick research, and there are in fact a couple of missions. There is the European Space Agency, so in moisture and ocean salinity, known as ESMOS, and also the NASA's Aquarius missions, which are specifically designed to measure water salinity. And we're looking at mainly the salinity at large bodies of water, such as oceans. But there are indeed also some applications or some techniques that can be used to assess water salinity in a smaller body of water, like lagoons and rivers. That can also provide information eventually for, and like in the case of Bangladesh, relevant information. So it's something that perhaps you guys need to investigate if it's something that might be provide solutions to the challenge, because I think what is going to happen is the increase of the of different salts, and also the acidity of this type of body of waters will increase with time due to climate change. And if there are options or technologies that can allow them to monitor these changes, I think it's worth really checking it out. Again, I don't have much information. It just came back from a quick research, but there are already existing missions from ESA and from NASA.
Okay, thank you very much, Kevin. Perhaps you can also include this in the chat. So for the information of the participants, and especially for Bangladesh. Okay, thank you so much also, Wim, for the answer, because it provides part of the solution of the problem. Okay. Do you mean your answer? Okay. Thank you for the information in the chat, Wim. You mentioned I was too late, but my answer was because it provides part of the solution of the problems faced. But I'm not sure I understand. Could you just open your microphone and give us some information, or explain what you mean, please?
Yes, I can do that. Because from the previous discussion also, I think having EO data is not the solution to the problem. It's part of the part of the solution. So you have to be very careful, I think, not to oversell the Earth observation as the solution to all the problems. That's basically, I think, previously we had also this discussion about satellite data, drone data, but also other geo information, socioeconomic data, and other data are also equally, or maybe even more equally important for facing climate adaptation, climate change mitigation and adaptation. So that's
Okay, no,
basically what I.
Great, thank you. That's very relevant. So that would be more a combination of data. It's not only Earth observation data, but you can develop these climate services using both of different sources of different type of data.
Yes, exactly. Yeah.
Okay, perfect. That's really, really important to take into account. And going back to the question 4, there are 2 answers: data to monitor the agricultural soil, and the other one is detecting climate vulnerability, planning resilience. Okay, let's take detecting climate vulnerability. So how can we do that? That's a interesting one. Let's take note of that one. I'm going to move to the slide here. So let's try to use this input that we receive on detecting climate vulnerability, planning resilience. So what is, if you think about this, what is the situation at the moment? Is not there a means to plan or detect climate vulnerability at the moment? What is the status of that? If the person who wrote this answer could give me some insights, that would be great. Because
I have response on this issue in detecting climate vulnerability and planning for future resilience. At present, we are just assessing vulnerability of the local people based on the local people perception, and also we are thinking about resilience planning based on the people's perception. We are not applying artificial intelligence or Earth observation data, but I think if we can apply Earth observation data in terms of climate vulnerability assessment in different areas and also future projection for climate resilience, then it will be best solution for climate resilience in Bangladesh.
Okay, Mohammed. So let's see. Let's go step by step. So at the moment, how do you detect or how do you plan any or take into account or do take some actions for planning to be more resilient regarding the climate vulnerability? How do you do it at the moment?
We just develop a scenario based on previous climate data analysis, how the climate change observed data, how temperature or rainfall or precipitation, etc., have changed, and also scenario of salinity from the field level and also people's perception. We just know vulnerability based on the people's perception and our national database, observed database developed by Bangladesh Meteorological Department. And also based on the people's perception, what type of intervention can be taken in those specific area. We just plan to provide the resilience intervention. But I think it is not fully sustainable in the specific areas.
Okay, so that's the present situation. So you do have at the moment some database, and based on that, you develop your resilience plans. But this is done in an automated way, or this is done manually. How do you use the database for the planning? Is this already automated? Like you take decisions based on information that is provided, I don't know, using the data and algorithms, and then you take decisions on that, or is it analyzed by looking at the data by people directly? How do you do that?
We conduct survey among the people and also discuss with different stakeholders like government organizations and local people to understand the climate vulnerability and to also understand the what types of intervention should be provided there. This is I can say this is only household survey.
Okay. Thank you very much. So now you describe the present situation. So how would you foresee the design of the future situation? What would be optimal for you? How would you improve what you have at the moment? Anything can be. You can think of having a magic wand and see, okay, I would like to have this in the future.
And future scenario we cannot develop because we based on people previous scenario, and we just assume what can be happen in future, but it is not a scientific solution.
Okay, but no, just think about, you have now the present solution, but if you would like to have, think like independently of any, yeah, let's see, you can think of anything that is possible. Anything at the moment is possible, just as a matter of.
I can say, for example, if we want to provide any intervention related to flood, we just collect information in the last few years, 30 or 50 years, what is the highest level of flood in the specific area. And if we find information, flood inundation was 2 feet from the mean sea level, then we provide intervention like flint raising or like other infrastructural support. It should be raised up to 2 feet or 3 feet. We just provide this information.
Okay, but then the desired situation in the future would be perhaps to have the analysis of this data done really automatically, and could ask for predictive results that you could use for your resilience plan. Something like that, or
Yeah, like that.
That you could have, let's say, you have an automated analysis of all the data that is filled in your database, let's say, and help you predict.
Yeah, Earth observation will help us to predict a future scenario, and we will be able to collect a specific information on relevant climate vulnerability, and it will help us to predict a specific scenario for the future.
So that you have, let's say, the analysis of data and give you possible scenarios for prediction and for prevention.
Yeah.
Okay, so now you have the present situation and you have the dream situation. Now let's see what steps do you need to reach that situation. So what would be the first step that you would take? So now, based on what you have at the moment, what is the first step that you need to go through to have the ideal situation?
To have the real, we understand to the real situation from the different locations. At present, we have to analyze our observed data from the national database, and then we have to understand the field level real-time scenario, and national data have to validate with the people's perception. And then using the Earth observation data, we can develop the future scenario.
Okay, so the first step would be, if I understood correctly, to analyze the existing data.
Yeah.
To analyze more thoroughly the existing data, and the second step.
Then validation with real-time data from the field level.
Sorry, could you repeat that, Mohammed?
At first analyzing the existing data, then it should be validated with the people's perception from the field level information.
Validated from people on the field.
Like the experts, I think you mean, right?
The experts in the field. Okay. Okay, now you define the second step, and the third step, what could be?
Then application of artificial intelligence to find the future scenario.
Use artificial intelligence
to find the future scenario.
To define scenarios.
Yeah.
Okay. And if we think about a next step. What would that be?
Then based on this scenario, we have to provide a specific support to the climate vulnerable areas. It may be agriculture, it may be water, or it may be health support.
Mm-hmm. Okay, so then provide some support based on those scenarios to the climate vulnerability areas.
Yeah.
And if you could think of a fifth step?
At present, I'm not thinking about future.
So that's
Four
the fourth
steps.
step.
Or
Okay.
maybe between the third and the fifth step, we can consider like trying to work on a plan as a step 4, according with the inputs that they are receiving from all the data, all the experts, and the artificial intelligence predictions and everything. And as a step 5, the implementing of those plans, maybe.
Yeah, I
Okay.
have so.
Okay, perfect. Thank you so much, Joanna. Thank you. Thank you also, Mohammed, for the use case. In this case, who are the users that you foresee?
There are multiple users. It will be totally climate vulnerable people, government organizations, non-government organizations. They will be users for this information.
Okay. That is a specific institution or several institutions involved?
Yeah. Several institutions will be user because there are a lot of institutions are involved with climate resilience activities in government and non-government sector. So all of them will be end user of this information.
So you have several users. Okay,
Yeah.
thank you so much. Thank you. Let's go then next to so we see that we want to describe the use case, establishing what is the situation at the moment and what is the dream situation, even if we have thinking like we have a magic wand to create this new situation and the steps that we need to go through in order to do that. So we have a use case at the moment. So now let's see a little bit the results that we have from our workshop today. Thank you for the participation from all of you. And we would try to define some problems and some functionalities required. So here some problems have been mentioned, and we specifically we're focusing on the project on the problem that Agapa shared with us, that is the impossibility of actually using satellite information due to the resolution in certain areas, because the resolution is not enough. So you need to do that actually with people going to the terrain, or also using drones and using other means like the micro satellite. So that was one of the problems that we identified here. The functionalities were have to capture this information from the field. So capture information that is relevant to monitor the land and the sea. But also we have another problem that was stated by Mohammed, that was the problem of detecting climate vulnerability and planning the resilience. So we actually use this problem to formulate a use case. So we mentioned what is the actual situation and what is the desired situation, and perhaps how can Earth observation can provide some data that can be combined with other data in order to have a resilience plan. So we did that, and we look into the steps of doing that and the type of users. In this case, Mohammed mentioned several users that are the institutions in charge of climate vulnerability in different sectors. And if we could think about a pilot, let's say we want to do a pilot of using this information and these technologies, how would you or where would you locate this pilot, Mohammed? How would you do that? What would give value for you in let's say trying certain solutions or trying certain services? What would be valuable for you? Yeah, you can. Mhm. Would you choose a sector, or would choose an area? for a pilot?
I think we should select one area for piloting.
For example?
For example, coastal one districts can be the piloting area for this intervention.
Okay, so one
Highly
district, one
salinity
coastal
affected
district.
area. We can select highly salinity affected area for piloting.
Yeah. Okay, yes, highly salinity area, for example. And what would be valuable for you to know in this pilot on located in the coastal area with high salinity? What would be valuable for you to
Um,
know or to learn or to actually obtain from that pilot?
if we can develop future resilience for agricultural intervention, then I think in one coastal districts, agricultural intervention can be the piloting for this intervention.
Okay, so that would be to develop yeah a, a resilience plan for agriculture intervention.
Yeah. Yeah.
Okay, great. Yeah, that's clear. Thank you so much, Mohammed. Thank you for this contribution of yours. So now we are almost at the end of the workshop. We have a few minutes to go, and I will go just to the next steps. So what we will do after the workshop, we would like to select some procurement challenges. We have conducted this workshop in the 5 application domains of Protect. So we have already some use cases from the other domains, that is from the domain on marine and coastal environments, from civil security and protection. We have also the domain on energy and utilities, sustainable urban communities. So we have a use case for all of the other domains, and we would like to select procurement challenges that public procurers and contracting authorities face in order to prioritize this challenge. So we try to vote and score. So you will receive more information after we process the results of the workshops to see which challenges are some that you relate to and are relevant to your organization. And we will define final use cases and these keywords from these use cases in order to perform a state-of-the-art analysis to identify where is the room for R&D, for research and development and innovation, with the looking at the possibilities of a pre-commercial procurement. And with these results, we will also have an open market consultation. So these are the next steps. So we will keep you engaged in this process. We will keep you informed in this process. And at this time, we will finish a little bit early, but you're welcome to make any questions, to make any comments, any suggestions for us. All of these are welcome, and please feel free to participate and to take these last minutes to share your thoughts with us. Anybody who would like to give any input, any feedback for us, any suggestion, or any complaint as well, you're welcome to do that as well. If not, then we will close the workshop with 5 minutes in advance. I want to thank you very, very much for being here with us today, for participating, for sharing the ideas. Perhaps it's not easy always to be in a workshop online with a camera, with recording, and to participate. So I really applaud those who have given the ideas and share with us your thoughts. If you have any questions, if you want to provide more information, you can always contact me. Here is my email address. I will leave it a little bit so in case you want to write it down, but most of you have received the link to this meeting from my email address, so you perhaps have it. So in any case, I want to thank you very much to all of you, also our colleagues from Aerospace Valley and also from Climate Kick for providing this very useful information, these very clear presentations on Earth observation and the taxonomy of climate services. Thank you so much, and have a very nice afternoon.
Thank you
Thank
so
you for
much,
organizing.
Alicia, for organizing.
Thank you very much.
Thank you.
Thank you.
Thank you. Bye.
Bye.
Bye, Alicia.
Bye bye.